section 4 is called equations in quadratic form. All right, so these are very similar to what we did yesterday because you might ultimately need to use the quadratic formula, okay? But these are what we're going to call next level problems, okay? They're a little bit harder. You may need to use substitution if it's got some weird stuff in it, okay? The other thing you can do is you can, once you get it into a perfect quadratic form, you can look and see if there's a GCF, or you can look and see if it's easily factorable. Bless you. Or you can look to see, maybe you might be able to use slip and slide. If you can't do any of those, then go quadratic formula. All right. So let's try one. Example number 1. We're going to start with 3x minus 2, bless you, squared minus 5 times 3x minus 2 minus 6 equals 0. All right, so anybody notice anything about this? Yes, it looks way more complicated than what we did yesterday, but next level, yes. Yes, so within the parentheses here, you have a 3x minus 2, and within the parentheses here, you have a 3x minus 2, okay? So we're going to say that y is equal to 3x minus 2. Okay, and then everywhere that we see the 3x minus 2, we're just going to say y. So this is y squared minus 5y minus 6. Doesn't that look a lot easier? Yes, okay, so we just used substitution. Now we look and see, okay, is there a GCF? Is it easily factorable? Can we use slip and slide? What do you think? Easily factorable, right? So I'm going to do 2 sets of parentheses. I know that y and y are going to get us the y squared. What 2 numbers will multiply to get negative 6, but add or subtract to get negative 5?
Negative 6 and 1.
Yes. Okay, so then we just need to solve them. If you need to do this step where you say y minus 6 equals 0, add 6 to both sides, go for it, but most of you are good enough, you can just recognize this one's y minus, or y equals 6, and this one's y equals negative 1, right? Okay, but since we substituted up here, we need to substitute back in. Okay, so if y equals 6 and I plug 6 in right here, I'm going to have 6 equals 3x minus 2. And I'm going to have negative 1 equals 3x minus 2. On this one, add 2 to both sides, so 3x equals 8. Divide both sides by 3, and x equals 8/3. Over here, let's see, add 2 to both sides, so 3x equals 1. Divide both sides by 3. We get x equals 1/3. Whoa, ran out of room. All right. Just make sure you substitute back in. That's kind of like, don't get here and go, oh, I'm done. If you substitute over here, you got to substitute back in. All right, any questions on example 1? All right, let's try another one. Example number 2. All right, we have the quantity 1 over 2x squared minus 5 times 1 over 2x minus 6 equals 0. Looks super complicated, right? But look inside the parentheses. What do you see? Same thing. So we're going to substitute. We're going to say that y is equal to 1 over 2x. So when we plug it in here, we have y squared. When we plug it in here, we have minus 5x. I went to plug it in there, and there's nothing to plug in. Okay. And then it's going to factor just like example number 1 did to y and y minus 6 and plus 1. Yes?
Did you mean to put y for minus?
Oh, and
You said minus 5x.
Sorry. So this one is y equals 6 and y equals negative 1. So then we have to substitute back in here. So 6 is going to be equal to 1/2 x. And negative 1 is going to be equal to 1/2 x. What's the inverse operation of multiplying by 1/2? Multiply by 2, right? So multiply this side by 2, multiply this side by 2. Oh, that 2's in, or sorry, that x is in the denominator. So, sorry. Nope. If 6 is equal to 1 over 2x, we're going to do the cross product. So we're going to go 1 times 1 is 1. 6 times 2x is 12x. Divide by 12. So it's 1/12. I didn't draw my fraction bar long enough. Okay. Over here, make that into a fraction. 1 times 1 is 1. Negative 1 times 2x is negative 2x. Divide by negative 2. So x is equal to negative 1/2. So the answers are 1/12 and negative 1/2.